So let's start, guys. Good afternoon, everybody. So last time we finished data transfer instruction. On Thursday, we're going to have a quiz on this section. Okay. Also, we're going to have a lab on this section as well. Okay. I want to tell you something very important. For the labs, there are pre-lab you have to do before you come to the lab. Okay. I noticed that some students don't do the pre-lab, and then you are going to struggle in the lab. You are not 3 hours are not going to be enough to think about all questions, especially the coming lab is a long lab. It has 2 parts. It's a long one. Okay, so try to do the lab before you come, and then if you struggle somewhere in the lab, you can ask the TS to help you. Okay, this is how can you make full benefit from the lab. Okay, guys. So today I'm gonna start the arithmetic instructions. I'm gonna teach in this section all the arithmetic instructions we have. Okay. So as you see here, these all the arithmetic instructions we have. So we have addition, subtraction, we have increment, decrement, we have complement, ones complement. So we have some instructions to do ones complement. Also, we have some instruction to do negate or to negate. So negate here means 2's complement. It means you multiply by -1. Okay. So if you have a number and you negate the number, it means you calculate the 2's complement of this number, or you multiply this number by -1. Okay. Also, we have some instruction to clear or set some flags and register some register for clear, as you will see. Also, we have some instructions for multiplication and division. Okay, so let's start. Let's start with addition first. For addition, we have only 3 instructions to add 2 registers. So there is no memory. You just add 2 registers together, no memory. Okay. The first one here, we have ABA. So ABA, this instruction actually is going to add a register A to register B, and then it's going to store the result in register A, as you see here. Okay. These instructions are inherent, and as I explained before, inherent means it does not need any operand, okay? Because the operation and the operands are already together in the instruction here, like this one, add B to A. You got what I'm saying? Also, we have another one, ABX. So this one actually is going to add register X. Again, no memory. Don't be. I know this will be confusing to students for some time. You are going to be confused with X, especially for X and Y. Do you mean register X or you mean memory location point by X? Okay, I know you'll be a little bit, and that's what I found in the last quiz as well. So here I'm saying register X. There is no memory here. So you are going to add B plus register X, and then you are going to store the result in X. Same thing here, ABY. So you can here add register Y plus register B, add the result in Y. Someone can ask me, but this is a word and this is a byte. So how I can add word to byte? Actually, this one always is going to put zeros here, always. Okay. So it's like there are some zeros here, and then you can add word to word. Okay, guys. These are the only instruction we have to add register to register. We don't have anything else. That's all what we have. Okay, guys. Is that clear? Any question? Okay. Let's see another set of addition instruction. In this addition instruction, we add a register to a memory location. Okay, so now I'm going to add a memory location to this memory location. As you see right now, it can be a byte or it can be a word. We add it to a register, as you will see now. Okay, so what we have here, we have only 3 instructions. The first one here, add a register A, and then you here this instruction needs only 1 operand. Okay, this operand has to be immediate value, or memory location. Okay. Again, as I said before, immediate value means hashtag. Memory location, it has different formats or different ways, as I explained before, like this one, it can be this one, it can be this one, and so on, as I explained before. So here, add A, register A, and then here you have to put immediate value, or here you have to write here a memory location. So this instruction you add byte to byte. So what's going to happen is you add register A, which is a byte, to a byte at memory, okay, a byte in memory or immediate value, and then store the result in A, okay. We have a similar one here, but this is for B instead of A, similar one. So as you see here, at B, and then here you have to write immediate value or memory location. So B should equal B plus memory or immediate value. Okay, so again, you add byte to byte. The last one here, this one is you add word to word. This is the only instruction we have to add word to word. So in this instruction, you add register D, which is a word, to memory location or immediate value, and then it's gonna store the result in D. So register D should equal register D plus immediate value or memory. Okay, guys? Any questions? Okay. These are the only 3 instructions we have to add register to memory. You don't have anything else. That's all what we have. The last set of instruction we have here, you add the register to memory or immediate value, similar to this one, But on top of this addition, well, I'm gonna add the carry flag as well. So that's what I'm saying here. Okay, so what we have here, I'm gonna add a register to memory location or immediate value and carry flag. Okay, so as you see here, we have only two instructions here. Add with carry register A, and then you put here memory or immediate value. Add with carry C and register B, memory or immediate value. So as you see here, what this instruction is going to do, this instruction is adding register A, byte, plus a memory location or immediate value, which is a byte, plus a carry flag. Okay, so if the carry flag is 0, I'm going to add 0. If the carry flag is 1, I'm going to add 1. Okay. For sure, you should be curious to know, so why you add the carry? You will understand it now, and you will understand this is very important to add a carry. Okay, so I'm going to explain why we need something. So this instruction here, again, are similar to these ones, but we don't have add D with carry. You got what I'm saying? So we have add A with carry, add B with carry. We don't have add D with carry. It's not here. Okay. This is all the addition instructions we have. So let me summarize them before I give you examples. All the addition instructions we have, number 1, we have 3 instructions to add register to register. Okay, A plus B, and then put the result in A, store the result in A. X plus B, store the result in X. Y plus B, store the result in Y. Okay, that's all what we have if you want to add register to register. Okay, the other group here, we can add a register to immediate value on memory location. So we have 2 instructions for bytes, and we have 1 instruction for word. Okay, so here you add A to immediate value memory location, add B. So here A should equal A plus immediate value on memory location. B should equal B plus immediate value on memory location. D, which is a word, so this instruction can add word to a word. Okay, the last set here, you can add a register to memory location or immediate value plus carry. Okay, and I didn't explain yet why you need something like that to add the carry. I'm going to explain it, so don't worry about it. For now, I'm going to explain it in detail. So now, add with carry A, which is a byte, to a memory location immediate value, also a byte. So here you add byte to byte plus carry. Here you add byte B, which is a byte plus carry. We don't have an instruction to add word plus carry. We don't have this one. Okay. Any question, guys, before I give you examples? Okay. So first of all, you can see here, if you want to add memory location to memory location, we don't have this instruction. Disagree with this. You see it, okay? We don't have this instruction. But again, that doesn't mean we cannot do it. You can do it. But the way you have to do it is, if I want to add memory location to memory location, number 1, I have to load 1 memory location to register A, and then I'm going to add register A to the second memory location. So I have to put a register in the middle. I cannot, for sure, if I have an instruction like what we did in move before, in move instruction. If I have an instruction to add memory plus memory, I would use it, but we don't have, right? So yeah, that's why. By the way, this observation you will see it in many instructions. Okay, not only in addition, but also in many instructions. In many cases, we don't have an instruction to add memory to memory directly, okay? That's why we are gonna use a register. So that's why we use a lot of load and to store instructions in your program. So what you have to do if you wanna add to memory location, I have to load one in a register, and then I'm gonna add this register to this memory location, as you will see in the examples now, okay? Again, if you go to, before I give you examples, and again, the best way to understand this part is just to, if you can understand the examples, this would be great. So here I want to show you. Yeah. So here again, in this chapter, in chapter 2, here in this slide, I summarize all the addition operations we have. Just I put them, all of them here. Is that okay? Also, I summarize subtraction. So let's first finish addition, and then we can look at subtraction. So now let's have examples to just better understand how can we use these instructions. Okay. Let's see this example first. I want to add a byte at memory location 1000 plus. I told you before, when I put bracket here, I mean the content of a memory location. Okay, 1000. So I want to add a byte at location 1000 plus a byte at the address 1002. Okay, so I want to add byte plus byte, and then I want to subtract the content of memory location 1005, and then I want to store the result in this memory location. Is that okay? So I want to add two memory location bytes, subtract byte, and then store the result in a byte. Okay. So let's see how can we do this in assembly. Okay. Number one, let's take it step by step. Number one, how I can add this byte to this byte, how I can do that. Okay. Again, as I have just mentioned right now, we don't have one instruction to add these two bytes together. Okay. So the way I'm going to do it, I'm going to take one byte, any one of them. I'm going to take one byte. I'm going to put it in a register A or B, for example, because it's a byte A or B. And then I'm going to add this register to the second byte. So that's what I did here. Look here, guys. So I'm going to take this one, put it in register A. So I'm going to say load A 1000. As I explained last time, here you are going to read a byte at 1000, put it in A. So I already got this byte, put it in A. And then I'm going to add A to 1002. Okay. So by doing that, so actually here, after these two instructions, register A should store the content of a byte at 1000 plus a byte at 1002. Okay, so I already did this part, but the result is stored in A. So I added these two bytes and the result is A. Is that clear, guys? Again, someone can ask why you didn't add directly. Again, because we don't have a register. Also, we are going to do this. We are going to do this thing all the time. Okay, because we don't have an instruction to add to memory location. I have put one in register and then add the register. Okay, is that okay, guys? So I finished this part. I already added 2 bytes. Okay, now I want to subtract. I'm sorry, I think. Okay, because I didn't. Let me finish. Let me explain subtraction because I need it here. Okay, subtraction is same thing. Let me go to the table here. I'm sorry for that. So So if you look at subtraction instruction here, guys, it's exactly same thing like addition, except you can see here you can subtract. Let me see. So look here, guys. First, if you want to subtract register from a register, we have only one instruction. Here we have 3. So let's make it here. Look here, guys. Okay. So here, if you, as I explained, if you want to add register plus register, we have 3 here. But here we have only 1. Okay, we have only 1. So what this instruction is going to do, you are going to subtract B from A. Again, no memory here, okay? So you just subtract B from A and to store the result in A, okay? So we have only 1 here for if you want to subtract register from register. Is that okay? Now, also, if you look at addition, I told you we have 3 instructions. If you want to add register plus immediate value, okay, or memory location. So we have 3 instructions. Same thing here. Also, we have 3 instructions. They are exactly the same. So here, this one, you can subtract immediate value or memory location byte from A, store the result in A. Same thing here, you can subtract immediate value or memory location byte from A and store it in B. So here you subtract byte from a byte. Also, here we can subtract a word. So here I can subtract immediate value or memory location, which is a word, from D, store the result in D. Is that okay? So these 3 instructions are exactly the same thing like this one, but these instructions are doing addition, these instructions are doing subtraction. Is that okay, guys? Okay. So the last thing here I want to talk about. Any questions so far? Same thing, okay? You can, but here you subtract memory location, or here you add. So if you look here, they are exactly same thing, okay? So anyway, the last instruction here, I told you we have 2 instructions here. In these 2 instructions, you can add a register plus register A or B plus memory location, immediate value plus carry. Is that okay? And I told you later, I'm going to tell you why I want to add the carry. So forget it for now, okay? We can do the same thing for subtraction. So we have 2 similar instructions, as you see here. They are exactly same thing, similar, but subtraction. So this one, subtract A with carry. Okay, so as you see here, what happens, I'm going to subtract immediate value. This is an immediate value or memory location, a byte. So I'm going to subtract a byte from A, register A, and also subtract the carry. So if you look here, look this one and this one, they are exactly the same, but here you add, here you subtract. Is that okay, guys? Any questions? Again, I didn't explain why sometimes we need to add carry, why sometimes we need to subtract the carry. You will understand it now, and you will find it's very interesting. Okay? Any questions? So these are all the instructions we have. So let's have examples on how can we use these instructions. So the first example here, I want to add 2 bytes, and we already did that. So as you see here, we added 2 bytes. Okay. Now I want to subtract this part. Okay. I want to subtract this part. Easy, because the result of this addition is stored in register A. So can I subtract a byte at location 1005? Can subtract it from register A? Yes, you can do something like that using this instruction. Sub-accumulator A, okay, 1005, okay. So here, this one, you are going to subtract the location, byte at 1005, a byte, you subtract it from A and store the result in A, okay. Again, don't be confused, as I said before, if you have just numbers here without hashtag, so that means these are memory location, okay. So I'm going to subtract a byte from A, store the result in A. So now, I did the addition, I did the subtraction, but the result is in A. So now the result of this operation is in A. But I'm asking you in this question to store it in 1100. Okay, that's why you have to store it in 1100 this one. Okay, guys. By the way, when I give like in quiz or in exam, when I give a question like this one to students, some students do everything correctly, but they forget to do the last part. So you did everything, but the result is in A or in B, and I'm asking you to put it in this memory location. You forget this one, okay? And you lose some mark because of that, okay? So it's very simple. You should not do that. Any question? Is that clear, guys? Okay, let's have more examples. I want to add a byte pointed by register X. So I want to add a byte in memory location. And this byte is pointed by register X, as you see here. So if you look here, so I want to add this byte pointed by register X, okay, to the next byte. I want to add it to the next byte pointed by x plus 1. Is that okay? So I want to add 2 bytes in memory. The address of the first byte is pointed by x. The address of the next byte, the second byte, should be pointed by x plus 1. That's okay? And I want to add these 2 bytes. I want to add these 2 bytes, and then I want to store the result in the location pointed by y. Is that okay? So let's see how can we do that. Again, this is a memory location. This is another memory location. Do you have an instruction to add 2 memory location? The answer is no. We don't have this instruction. So what can we do? What we're gonna do? I have to load this instruction in a register, and then I can add a register to this memory location, and then I'm gonna store the result here. That's what I'm gonna do. So if you see here, guys, now I want to read the byte pointed by x. This is the way we do it, as I explained before. 0, x, 0, x. Here you are gonna read the byte pointed by x. Is that okay? So here I'm gonna read the byte from memory. Which location? The location should be in x. The location in x. Okay. Still some students confused here. Okay. Now, so I read the first. Now I read the first byte. I store it in register A. Okay. Now, so I have the first one in A. Now I'm gonna add A plus this one. Okay, that's what I did. Look here, guys. I'm gonna add register A to a byte in the memory, which is x plus 1. That's why I put here 1. Okay. So what this instruction is gonna do is gonna add A to the byte at the location x plus 1. Is that okay, guys? And then I'm gonna store the result in A. So what I did so far using these 2 instructions, I added these 2 bytes, but the result is stored in A. Okay. Here I'm asking you to put the result, to store the result in the location pointed by Y, and that's what I did. So now here I'm gonna store A in the memory location pointed by Y, 0, 1. Any question, guys? Any questions? Okay. Let's see more examples. I want to add number 3, not memory location, immediate value. Number 3. I want to add number 3 to the memory location 1000, and I want to store the result at 1000. That means I want to do something like that. The content of 1000 should plus 3. I'm going to store it in 1000. So it means I want to add 3 to the content of 1000. Okay. So again, how can you do that? Do you have one instruction to add immediate value to memory location? No, we don't have this instruction. Okay. So the way I can do it, I have to use a register. So I'm going to load register A with 1000. So I'm going to read the byte. I'm going to read the byte at location 1000, the content of 1000. I store it in register A. So after I execute this instruction, A should equal the content of 1000, a byte at 1000. Okay, whatever is there at 1000. Okay, and then I'm going to add number 3 to A. So this instruction, because I told you what should come after this instruction can be immediate value or memory location. And this instruction is used if you want to add bytes. So here A should equal A plus number 3. Okay, so now I added 3. Many students stop here, they don't continue. Okay, so now you added this byte to 3. Now you have to store, but the result is stored in register A. The result is not in 1000. That's why you have to return it to 1000. That's what I did here. Store 1000 to memory location 1000. Store A in the memory location 1000. Okay, guys, that clear? Any questions? Yeah. Let's have more examples. Now, this time, I want to add the word at memory location 1000 to a word at memory location 2000, and then store the result at 3000. Okay. Again, don't be confused, guys. When I say a word at 1000, it means I need 1000 and next one, 1001. Okay. When I say I'm going to store a word at location 3000, I mean 3000 and next one. Is that okay? So here, that's exactly what I want to do. I want to add a byte at location, a word at location 1000, which is 1000 and 1001. I want to add it to a word at location 2000, which is 2000 and 2001. And then I want to store the result at 3000, which is 3000 and 3001. Is that okay? Okay. So do you have an instruction to add word memory location to a word memory location? No, we don't. So what can I do? I have to put this one in a register, which register D. Okay, and then, by the way, this is the only instruction we have that can add word to word. So here, I'm gonna read a word at 1000. I'm gonna put it in register D. Is that okay? Sometimes I make some typos here. I'm not sure if this is triple D or not. This one, I think it's triple D, but this one, I think it's double, not triple. Anyway, you have the slides, you have the tables on the slide. So if there is misspelling here, it's easy, you can correct it, okay? And really, I'm not very worried about misspelling, because if there is misspelling, Code Warrior is gonna give you a warning. Code Warrior is gonna tell you, I don't recognize this instruction, okay? So you should, if you see a message like this one coming from Code Warrior, that means there is misspelling, okay? Because it doesn't understand the instruction. So here, I'm gonna read the word at location 1000. I'm gonna store it in register D. This is number 1, okay? And then I'm gonna add this word, which is in D, plus a word at 2000, okay? So what this instruction is gonna do is I'm gonna add register D, which register D now is storing this word. It's in register D, and then I'm gonna add this search. I should put brackets here if you are confused. Okay, so I'm gonna add here to this word. I'm gonna add to this word. So now I added this word to this word, and now the result is in register D. Okay. Now I'm asking you here to put the result, store the result in 3000. So now you store again, guys, because many of the instruction I'm going to teach in assembly does not allow, do not allow to do operation directly on memory location. So the way you have to do it, you have to use load and to store. Okay, you have to use registers in the middle. Any questions? Okay, so now I almost finished everything here except one thing I didn't teach yet, which is why sometimes I need to add carry. You told us we have a couple of instructions here. Yeah, here in this instruction, guys, I'm gonna add register A plus immediate value or memory location plus the carry flag. Okay, whatever is the carry flag. If the carry flag is storing 1, I'm gonna add 1. If the carry flag is storing 0, I'm gonna add 0. So why sometimes we need to do something like that? I understand I have 2 numbers, bytes or words, and I want to add numbers. Yeah, I can understand that. But I don't understand why sometimes I need to add the carry. Okay, I'm gonna explain it now, and you'll find it very useful, very, very useful. Okay, look here, guys. Now, I already explained, we already have an instruction to add byte plus byte, right? So, and also we have an instruction to add word plus word. So if your number is a byte, you can add byte plus byte easily, right? If your number is a word, you can add word plus word using one instruction easily, right? However, what if your number is bigger than a word? For example, I want to add 32 bits plus 32 bits number, okay? And I want to store the result in 32-bit number. Okay. Number 1, do you have any instruction to do that? No, we don't. All what I have, I can add word plus word or byte plus byte. So how can you do this one? How can I add 32-bit number plus, for example, or bigger? Any number here, I am giving example on 32-bit number, right? However, I'm saying any number bigger than a word, okay? Because all what we have, I can add byte plus byte or word plus word. Okay, so if you have a number that's bigger than a word, how can you add these numbers? Okay, as just an example, if you have 32-bit number and 32, how can you add them together? Okay, someone can say, I'm not sure. We need to discuss is that correct or not. Someone can say, no, that's easy. 32-bit number is actually byte, 4 bytes, right? 32-bit number is 4 bytes. So the way I can do it, I'm gonna add these 2 bytes together using word addition. So I can add this word to this word, right? And then the result will be this part of the answer, okay? And then I'm gonna add this word to this word, and the result will be here. Do you think is that correct? So can I use 2 word addition instruction for words? I'm gonna add these 2 words together, and then I'm going to add these 2 words together. Do you think is that correct? Any guess? So can I use 2 addition instructions here? Yeah, like this one, addition instruction. Okay, can I use this instruction twice to add these the less significant word and most significant word? Can I add them this way using twice this instruction? The answer is yes or no. Can we? Is the result will be correct? The answer is no, the result is not going to be correct. Why? Because maybe there is a carry resulted here. You just ignored this carry. You told me if you want to do addition, okay, so I'm going to do separately. I'm going to add this part and then separately I'm going to add this part. If there is a carry, I'm going to ignore it, right? So the result, that's why the result is not correct. So what should happen is you can add this part, it's totally fine. However, if there is a carry resulted from this operation, I have to add it here. It has to be taken into account here. That is why they made instruction to add a carry. You got what I'm saying? So because of this instruction, you can add a number with any length to any other number. Okay, not only 32, with any number. The way you should do it, the first byte or the first word, it can be normal addition. So first you do normal addition and then add with carry, add with carry, add with carry, add with carry, and so you got it? Because if there is a carry, you have to take it into account. So conclusion. Add with carry instruction, they made it so that you can add numbers greater than words. If you have numbers that are greater than words, you can use this one. Is that okay? So what happens here, this one is going to be normal addition. And as I explained before, every time you execute an instruction, flags are updated automatically. So this instruction are going to update the carry flag. That's what we always do, right? So now, if the carry flag is 1, so this instruction should add the carry, whatever the carry is. 0, it's going to add 0, 1, it's going to add 1. Is that okay? So let's see how can we do it. So here, first you can add without carry, normal addition, without carry, at the very beginning. First you have to take it right to left, not left to right. So now you have to take it right to left, not left to right, okay? So the first one here, this I can add word plus word without carry. And we have this instruction. And then I'm going to add byte plus carry, add with carry. And then byte plus byte with carry, and so on. Byte plus byte with carry, and so on. Someone can ask me, why byte? Why you don't add word plus carry? Simply because we don't have this instruction. If you go back, you see here, for carry, we can only add A or B. That's it. We don't have a word with carry. Okay, guys. Any questions? Okay, let's have an example. To see how can we use it. Okay, guys. So let's see this example. Here, I assume this is where I'm storing 32-bit number at the location 1000, 1001, 1002, 1003. So this number is stored in 4 locations in memory. Okay, this only one number, 32-bit number, is stored in 4 locations: 1000, 1001, 2, 3. Okay, same thing. 1004, 5, 6, 7. Okay, we agreed the first byte is the most significant. That's what we do in this course. That's why I put 1000 here because it's the most significant. That's why I put 1004 here because it's the most significant. So we have 2 numbers. Every number takes 4 locations in memory, as you see here, and this one takes 4 locations. All what I want to do, I want to add these 2 numbers, and I want to store the result in 4 locations, as you see. Is that okay, guys? So this is 32-bit number plus 32-bit number. This number is stored in these 4 locations. This number is stored in these 4 locations. I want to add these 2 numbers. I want to store the result in these 4 locations. Okay. So how can we do that? The way you are going to do it, now, as I have just mentioned right now, I'm going to add word plus word, store the result in a word, and then I'm going to add byte plus carry, store the result in this location. Add byte plus carry and store the result in this location. Okay? Do you understand the idea before I talk about the code? If you don't understand the idea, you are not going to understand from the code. Okay? So you understand now what you want to do? Okay, let's see how can you do it. Number one. Now, I want to add word plus word, store the result in a word. How can we do this one? Very simple. We have only one instruction to do that. Okay, only one instruction, which is add D, this one. So I'm going to use this one. Add D and then memory location here. So here, the way I'm going to do it, I'm going to read this word at 1002 and 1003. I'm going to put it in register D. And that's what I did. If you see it, guys, load D. So this one, I'm going to read the word at 1002 and 1003. I'm going to put it in register G. Is that okay? So now this one is in register D. And then this instruction here is going to add register D plus this one. Okay? That's what I did. So I'm going to add register D plus the word at 1006. And then I'm going to store the result in register G. So now I added this word to this word, and the result is stored in register G. Is that okay? What should I do now? I have to store D here. I have to store D. That's what I did. So now I'm going to store D in 1012. So the 12 and 13. Is that okay, guys? So now I'm done with this part. So now I'm going to move to this part. So what can I do now? That's very easy. I want to add byte plus carry. Okay? We don't have an instruction to do that. So I'm going to lose this one to a word, to byte, as you see here. So I'm going to take 1001. I'm going to put it in register A, as you see here. And then I'm going to add register A plus 1005 plus carry. Is that okay? Again, the result is, so now I added this one plus carry. But now the result is in A. Okay, so I need to put the result here. So that's why I'm going to use the store here. Okay. What about this part? It's the same thing. Again, I want to add byte plus carry. Okay. And then I'm gonna store the result here. That's what I did. So now I'm gonna read the byte at location 1000, as you see here. Okay, I put it in register A, and then I'm gonna add register A, okay, plus 1004 plus carry here in this operation. And then the result is in A. So I have to store it in 1010. Okay, guys? Any questions? Any questions? But there is a mistake here. Yes.
So adding with carry is built in to whatever's the carry flag is automatically added.
Yes. So you can think the carry flag like a register. When you add register to register, how this be done? You just add the content of this register plus the content of this register, right? The carry flag is the same thing. It's just like a bit, a flip-flop. So it's gonna add whatever there. Because I'm saying it's like a register, but it's one bit register. You can take this. Yes. So if the carry is 1, I'm gonna add 1. If it's 0, I'm gonna add 0. Okay. So there is a mistake here. So what is the mistake? I'm gonna tell you what is the mistake. Look here, guys. I told you I want to add word plus word, right? And the carry resulted from this operation. It has to come here. This is the carry. So if there is 1, it should be 1 here. If there is 0, it should be 0 here. Is that right? In order, that's how it should work. Okay. So look here. This instruction, we agreed before. Every instruction should update the flags. So every instruction should update the flags. Okay. So when you do this addition, okay, so this one is gonna update the carry flag. Here I care about the fact is actually it's gonna update all the flags, but now I care about the carry flag. So here when I do this addition, this one is gonna update the carry flag. Okay. However, I'm gonna use a store instruction. This instruction also should change the flag, and then I'm gonna do load instruction. This also will change the flag, and then I'm gonna do add with carry. So add with carry, you actually is gonna add this carry, not this one. You got the problem? So the correct thing I have, in order for it to work, in order to get a correct result, the carry resulted from this operation should be added here. Should be added here, right? However, these two instructions are gonna change the carry. That means maybe there is one here, but this one put zero. So I'm gonna add the last. I'm gonna add the last carry. Okay, the last value for the carry, right? So what I'm gonna add here, the last value of the carry is gonna be added here. You understand what I'm saying? You understand the problem? The problem is I want to add the carry resulted from this operation, which was here. However, I need to do these two operations as well. These operations are going to change the carry. So when I come here, I'm not going to add the carry resulted from this operation. I'm going to add the last carry here. Is that okay, guys? You understand the problem? You understand the problem, guys? Okay. Actually, yeah, this is a good point. This is a very valid point. But actually, we don't have a problem here. No problem. We are okay. It should work. Can anybody guess why we don't have a problem here? We should have a problem because the carry I'm going to add here is going to be this carry resulted from this operation, not this one. Yes.
Storing life doesn't affect the carry.
That's true. That's true. The only way that we don't have a problem here, the only way is that if you put instructions here, if this instruction does not change the carry. You got what I'm saying? And that's true. So the store and load instruction don't change the carry. Is that okay? That means whatever carry resulted here is going to be the same carry. I'm going to get it here, right? Because this one does not change. So if the carry is 0, it's going to continue 0. If it is 1, it's going to continue 1 because these two instructions, load and store instruction, don't change the carry. Okay? That's why this time is going to work. However, if you put here any instructions that change the carry, the result is not going to be correct. Is that clear, guys? So how did you know that the load or store instruction don't change the carry? Okay? If you go to the instruction set, so here from the instruction set. So if you go to the instruction set, guys, for example, let's look, as I explained before, you can know, for example, let's look at addition. For example, this is add with carry. Add with carry is going to change the carry flag as you see here. So this triangle means it changes it. This dash means it does not change it. Okay. So you can see here, add with carry, they are going to change all the flags, the 3 flags, 4 flags here. Okay. Let's look at the load. If we go to search for load, or we can go to load. Yeah, load. Look at load here, guys. Load, the carry flag is the first one here. The first one. So here, load instruction, they don't change the carry flag. Okay. Sorry, here, this one. However, they put 0 in the B flag. So always they put 0 in the B flag. They change the negative flag and also the 0 flag, but they don't change the carry flag. Is that okay, guys? Is that clear? So this time it should work. It should be okay because here I'm putting here instructions that don't change the carry. So whatever carry resulted from this addition here is going to be the same carry that you are going to use it here. Is that clear, guys? It's a little bit tricky, but it's important to understand. Any questions? Yes.
Why is there a 0 on the flag?
Why they made it this way? I don't know. They made it this way because maybe the overflow flag, signed overflow may never happen, right? When you load, you can what I'm saying? So again, they made it this way. They made the hardware so that you would see. You get what I'm saying? They made it this way. My guess, if you ask me my guess, overflow should not happen anyway when you use load, right? Because you're not adding. The number is not going to get bigger. You get what I'm saying? So overload should not happen anyway. That's why for carry, they are not going to change the carry. You know the carry is used for unsigned overflow, right? Because overflow is not going to happen anyway, so they are not going to change the carry, right? Also for overflow, this one this is for signed overflow. Okay. Also, sign overflow shouldn't happen anyway because you are not adding. You got what I'm saying? But why they put 0? I don't know why they put 0. But anyway, this flag is useless. So I don't need this flag anyway here because overflow cannot happen, right? Now, so now you should now you guys explain how can you do addition using in assembly. Also, I explain the idea of adding a flag. Why I need to add flag? I need to add flag so that if you have a number bigger than a word, you can add these numbers together. Because add with carry, because when you do binary addition, if there is a carry, you have to add this carry. Otherwise, you're going to get wrong results. Okay. Now, I want to talk about subtract with carry. Okay. Same thing. We have here an instruction. Yeah, here. Yeah, look here, guys. We have subtract with carry. As you see here in this instruction, we subtract carry. Okay. By the way, in this instruction, if you see what is written here, the carry flag, we call it borrow flag. Borrow flag. Can you see the word borrow here? Okay. So here in subtraction, the carry flag, we call it borrow flag. Borrow flag. Is that okay? Why? Because you know the idea when you borrow in the subtraction, this if the carry flag is 1, that means there is a borrow, you borrow some value. You got what I'm saying? That's why the carry flag is actually, you call it borrow flag, okay, in subtraction. So the idea here is, so here the carry flag acts as what we call borrow flag. Okay, borrow flag means if you do subtraction and the carry is 1, that means there is a borrow. So the result you got here. So if you do subtraction and you did a borrow, so the result you are going to get here is with the borrow. So you got here a result. This result after you borrow and you subtract, this is the correct result. So there is a borrow. Is that okay? So same thing like addition, If there is a borrow, this borrow should be considered in the next subtraction. So if you do subtraction this way, guys, and then you borrow, if there is a borrow, okay, that means I have to subtract 1. Okay, that's why we have here subtract with borrow or subtract with carry. Right? Again, let me say it in a very simple way. This is normal subtraction. In normal subtraction, if you do normal subtraction and you find the carry flag is 1, what it means? Okay, if you do normal subtraction and then you find that the carry flag is 1, that means there is a borrow. And the result you got here, this is with the borrow. So this is a correct result, but with borrow, after borrow. Okay. So when you subtract the next one, you have to take into account this carry flag or this borrow. So you have to subtract 1. Okay. So that's why you have here similar to the idea I have just explained for addition. So if I want to subtract 32-bit number from 32-bit number, the first, as I did before, the first word, I can subtract word from word using normal. Here, when I say normal, I mean without carry. Okay, maybe you are confused when I say normal. Normal means without carry. Normal addition without carry. So you can do here subtraction without carry. And then if you do this subtraction and there is a borrow, that means the carry flag should be 1, right? But here, when you subtract this one from this one, when you subtract this byte from this byte, you have to subtract also the carry. Okay. So here you have to do subtraction with carry, and so on. So this idea is similar to the idea addition with carry, but here subtraction with carry. But again, we call it with borrow because this carry acts as a borrow. Okay. Any questions? So if you subtract the 2 numbers and the carry was 1, it means this result is correct if there is a borrow because you already got 1 from here, borrow from here. Okay. Any questions? Okay. Now, I told you I'm done with addition and subtraction. So let me go back here. So here, this all the arithmetic operations we have. We have addition, subtraction. we have increment and decrement. And increment means you add 1 all the time. Yes, all the time. So increment means increment by 1 all the time. Decrement means you subtract 1. So we have instructions here to increment means you add 1, or decrement you subtract 1. Also, we have an instruction for complement, which one's complement. We have for negate, this one should calculate the 2's complement. We have an instruction for clear and set. So these are very easy instructions. I'm going to teach them very easy. Finally, I'm going to teach multiplication and division. That's all what we have. Okay. So, okay, let's see increment. I told you increment means you add 1, and we have here decrement. Decrement means you subtract 1. Okay. Okay. So this all the instructions we have. You can increment A. This is an inherent instruction. You don't need to write any operand here. Increment A. So what this instruction is going to do is going to add 1 to register A, store the result in A. So no memory here. No memory here. Okay. Increment B. So this one is going to add 1 to B, store the result in B. We have increment X. One word. There is no space here. One word. Increment Y. Okay. Increment S. S here for stack pointer, as I told you before, and I'm not gonna. We're gonna use it later. Okay. So that's all what we have. We also have decrement. So we have decrement A, decrement B. We have decrement X, decrement Y, decrement stack pointer. Is that okay? The last 2 instructions we have, you can say increment, and then you can put a memory location here. And this one is going to increment as a memory location. And also, we have another one here for decrement. So this one is going to decrement as a memory location. However, this increment and decrement are for bytes, not words. We don't have increment for word or decrement for word. But again, that doesn't mean you cannot do it. You can do it, but using multiple instructions, as you will see right now. Okay, so all what we have, I can increment a memory location, a byte, or decrement a memory location, which is a byte. Okay, guys. So let's see examples here. The first example. Let's see. I want to decrement register D. I want to decrement register D. Okay. So let's see how can you do it. Do we have here decrement for register D? No, we don't. Okay, guys, we don't. We don't have this instruction. If we have it, I would use it. Okay, so we don't have decrement for register D. Someone can say, okay, that's very easy. I can decrement register D is actually two bytes. 1 byte is B, 1 byte is A. Can I say decrement B? If I want to decrement B, can I say decrement B and then decrement A? So if I do these 2 instructions, is this one is going to do decrement for D? Is that right? True or false? Is that right? Can I do that this way? It's like you have 2 bytes here. I'm gonna decrement 1 from here, and then I'm gonna decrement 1 from here. For sure, that's completely false. That's not what I want to do. What I want to do, we have a register D, and then I want to decrement 1 from the whole register. It doesn't make sense to split this register into 2 pieces, okay, B and A, and then decrement 1 from here, decrement 1 from here. It doesn't make sense. Also, it doesn't make sense just to decrement 1 from B. You got what I'm saying? You know why? So, for example, can I use only decrement B so that you can decrement D by 1? No. You know why? Yes, because there may be a borrow this way. This borrow should be taken into account. Okay. Sometimes it's going to work, by the way. That's funny. Okay. Sometimes it's going to work. If there is no borrow, this way, if there is no borrow this way, so actually when you decrement B, you are going to decrement D, right? So it should be the same thing. However, if there is a borrow, right? If there is a borrow, in this case, it's going to be false, because actually there should be, the borrow should be taken into account. Anyway, so the easy way, I just want to tell you, as you will see, what I want to tell you is, look, and you will see it right now, guys. So what I want to say is, sometimes, as you will see right now, when I do the operation on B and the operation in A is going to be same thing if you do the operation on G, like complement, as you've seen right now. But sometimes it doesn't work. So in this case, it doesn't work. So how can I decrement D? Again, I don't have one instruction to decrement D. I cannot decrement A and decrement B. I cannot also decrement B only. So the easy way you can do this one, you can do subtract 1, right? The easy way, right? You remember this instruction, subtract D and 1. So this instruction is going to be D. So this instruction, this is immediate value. Don't be confused. There is no memory here. This is no memory, immediate value. So it's going to be register D should equal register D, take away 1. Okay. Okay. Let's see another instruction here, guys. When I say increment 1000, I told you here you increment a byte, not a word. Okay, not a word. So if you want to do it I'm going to tell you why I like this instruction. I'm going to tell you why. I like this instruction because if you don't want to do this instruction, if you want to do it in a different way, look here, you're going to need 3 instructions to do that. Okay. For example, I'm going to read 1000, put it in register A, increment A, and then return it back, A back. Okay. So this 3 instruction can do the same thing like this one. So why I would use 3 instructions if they can do the same thing like 1 instruction? Is that okay, guys? Is that okay? So here, this one is equivalent to these 3 instructions. Now, and this may be a question in a test, in a quiz, whatever. What if I want to increment the word, not a byte, at 1000 this way? Okay. So can I say increment, for example, here 1000, and then we have 1001. Can I say increment 1000? Increment 1001, is that right? For sure, that's not right, because 1000, same thing as I explained for D. This is 1000 is here. 1000, I'm sorry, I think 1000 is the most significant, and 1001 is here, right? So if I say increment, that means you have to add 1 to everything here. Okay, so it's not correct to add only 1 here, and it's not correct to add 1 here and 1 here. It's not correct. Okay, so the easy way to do this one, I can read the word at 1000, put it in register D, and then I'm going to add 1 to register D, and then I'm going to return it back. Can you see it this way? Okay, guys, can you see this way? So I'm gonna read the word at 1000, as you see here, and then I'm gonna add 1, and then I'm gonna return it back. Any questions? Okay. By the way, just I think we had a problem before with increment and decrement. Look here, I want to tell you something very important, very tricky, very important. Look here, guys. If you do subtraction, if you do like decrement A, or if you do subtract A, 1, these 2 instructions should do the same thing. You agree? They should, right? Because here you decrement A. That means in both of them, A should equal A, take away 1. Both of them, right? You do this way or this way. But there is a very tricky difference between them. You know what is that? Flags. There is a tricky difference between them. What is that? Flags. Both of them change the same flags? If yes, so they are identical. Okay? Otherwise, no. So I'm going to check the flags right now. Is there other difference? Yes, there is other difference. The other difference is this one, if you care about efficiency. So this one is much more efficient. This one is much more efficient than this one, right? So this is another difference. So what do you mean by efficient? I mean by efficient memory location. So this one is going to take more memory location than this one. So the machine code for this one is more than this one, okay? Also, the speed. This one is faster than this one. You got what I'm saying? So this is another difference. But now let's look at the flex. So if you care about efficiency, so this one is better than this one. Also, let's look at the flags because this is very important. I think it happened before. Some student, let me remember. Yeah, I think it was like a tricky problem. Some student, I wanna after I do decrement, I wanna look at the zero flag. So what happened? A student used this one, thinking that this one is gonna change the zero flag, but indeed this one didn't change the zero flag. Okay, very tricky, right? So that's why the program was not working correctly. So let's see. It's very easy. So you can see here, if you go to decrement. Yeah, so here, decrement, look here, they change the zero flag, but they don't change the carry flag. So these ones don't change the carry flag. So let me see. Yeah, I think I mean all of them change. I mean this, maybe this one. So this one does not change the zero flag, but this one still changes the zero flag. So I think the problem, let's look at increment. I think the problem was in increment. So for example, let's look at increment here. Increment here, it does not change it does not change the carry flag. You got what I'm saying? So if there is a carry, this one is not gonna, if you keep incrementing, okay, and there is a carry, this one is not gonna change. I think addition or subtraction change everything. Let's see. Anyway, this just, you may not need it. However, this also something you should take into account when you use the instruction. If you need the flag, if you need a certain flag, you have to make sure this instruction, it changes the flag. So if you look at subtraction, it changes all the flags. Decrement does not change one flag, the carry flag. Okay, if it doesn't matter to you, they are exactly the same thing. Okay, but there is another minor difference, as I told you, maybe in also in the machine code is also another thing you can look at. If it doesn't matter for you, they are exactly same thing. Okay, it doesn't matter. Again, you answer them, same guys. So anyway, we have two instructions. They do the same thing. Maybe there is a minor change in the flags. If this flag doesn't matter to you, that means you're not going to check this flag. That's what I mean by it doesn't matter to you. You don't need to check this flag after execute this instruction. So in this case, they are exactly the same. Okay. Any questions? Easy. I think it's easy, I hope. So anyway, let's come to complement. So complement instruction, I finished, by the way, increment, decrement. So we don't have many. So that's all what we have here. Increment A, decrement A, increment B, decrement B, increment X, decrement X, increment Y, decrement Y, stack pointer, and then you can increment a byte in a certain memory location, decrement a byte in a certain memory location. Let's see what addressing mode you can use here. So also this is something you can, I told you can look here. So if you can see increment, let me come back. Yeah, look here, guys. So you can use all the addressing mode here. So you can use extended addressing mode. Also, you can use indexed addressing mode. So you can, after increment, you can use any addressing mode for memory. Okay, all of them are okay. Now, I'm gonna move to two more instruction: complement and negate instruction. Okay, you can very easy. You can tell from the English name complement. So this one is gonna do the once complement. So when I say, and that's all what we have. We have complement A, complement B. So what this instruction is gonna do, actually, it's gonna be A should equal A complemented. Okay, so flip the bits. Same thing for B, and then you have complement for a memory location, and this memory location is a byte. That's all what we have. So for complement, we have three instructions. You can complement, flip the bits of A and store the result in A, complement B, and also you can complement a memory location. Okay, so you flip the bits of this memory location. Okay, again, as you see here, if A is equal to this value, you complement A. So after you execute this instruction, this is how A should look like. You flip the bits. Is that okay, guys? Again, that's all what we have. We have only 3 instructions. Very easy. Again, this is a complement for a byte. We don't have complement for a word, for memory location, or even for register. So this complement for bytes. Now I want to talk about negate. Negate means you calculate the 2's complement. And as I explained before, when you calculate the 2's complement, you actually multiply the number by -1. Okay? That means if you have a register A just storing number 7. After you negate A, you actually should be -7. Is that okay? Anything, for example, if it is -50, if you negate A, you are going to get 50. Okay, guys? So this is the meaning of negate. So negate means I'm going to calculate the 2's complement. And as I explained before, the 2's complement is actually the 1's complement plus 1. That's okay. So we also, similar to complement here, we have only 3 instructions. You can negate A, you can negate B, you can negate a byte, which is a memory location. Okay? That's all what we have. So let's see examples. So for example, I want to complement a byte at memory location 1000. How I can do that? Very easy. Complement, COM, and then you put here 1000. You complement 1000. Is that okay? That's it. Now I want to complement a word at 1000. I want to complement a word at 1000. You know how can we do that? So I can complement 1000 and then I can complement 1001. Right? So if you have a word, so here, this is 1000 is here, 1001 is here. Is that okay? So I'm gonna complement this one and then complement this one, separate. Yeah, it works here if they are separate because you just flip the bits. There is no carry, there is no borrow. You should not worry about it. Just flip the bits. Yes. So here I'm gonna complement 1000 and then I'm gonna complement 1000. There is another way, but it needs more instruction. As you see here, they are the same. So for example, I can read a word at 1000, put it in register D, and then I complement A, complement B, and then I return G back. Yes, you can do this one, but this one is maybe easier. Is that okay, guys? So you read the word, you put it in register D, and register D is 2 pieces, A and B, then I complement A, complement B, and then return D to 1000. Is that okay, guys? Okay. Let's have another example. If you want to negate a word, how can you, negate a byte? How can you negate a byte? That's easy. You can say just negate, and then you put here 1000. So by this way, I can negate the byte at 1000. Is that okay? So how I can negate a word? If you have a word and I want to negate it, okay? What negate means? If you have a word is this way, I want to negate this word. It means I have to calculate the 1's complement first, and then I have to add 1. Is that right? That's how it is. Okay. So how I can do it? Can I do negate and negate? Is that work this way? No, it shouldn't work this way because if you do negate here and negate here, as I did here was complement, it's okay because complement you just flip the bits. But when you do subtraction, it's not okay because if there is a borrow, it has to be taken into account. You got what I'm saying? So anyway, so here for sure this is false. I cannot negate and negate because I cannot treat them separately, right? As I did complement, it was okay because complement you flip the bits. You got what I'm saying? But if you add or subtract here, you need to add 1. Anyway, so the way, how can we do it? The way I can do it, guys, very easy way. So number 1, I can negate here. So here, number 1, I can complement and then I add 1. Pretty simple, right? So here, what I did, I'm gonna read the word at 1000. I'm gonna read the word at 1000. Then I'm gonna complement A, complement B. So now I complemented this word at 1000. Okay, but it's in register D. So number 1, look here, guys. This is 1000 and 1001. So I'm gonna read this word I'm gonna put it in register D. This is number one. This is what this instruction is doing actually. Number two, I'm gonna complement D. So I'm gonna have like D dash or whatever you wanna call it. Okay, D prime, whatever. So here I complement D as you see here. And then I'm gonna add 1 to D. So now, and then I'm gonna return it back. You see? So number one, I'm gonna read this word, put it in register D, and that's what I did here. Number two, I'm gonna complement D, and that's what I did here. Then I'm gonna add 1, and that's what I did here. Okay. Then I'm gonna return the register D back to here, and that's what I did here. Okay. Any question? Okay. Now the next instruction I want to teach, they are set and clear instructions. So what this instruction are doing, you can tell from the English name. Clear means 0. You put 0. Set or reset. Set, this is for clear. Clear means you put 0. Set means you put 1. Okay. So number one, we have clear for registers, like you have clear A. So clear A, so actually you are going to put 0 on register A. Clear B, so that means you are going to put 0 on register B. So A is equal to 0 if it is 0, 0, 0, 0. All the bits are zeros. You know what I'm saying? So this one, A is equal to 0, B is equal to 0. Also, you can clear a memory location, which is a byte. Okay. So clear a byte, what it means, all bits are zeros. You clear it. The result is the value is 0, right? So we don't have set for bytes. So we don't have set instruction for bytes. Okay. Someone can tell me, now I can clear A using two ways. I can say clear A, that's true, or I can say subtract A. Or sorry, not subtract. I'm going to say load A with number 0. Yes. So both of them should be okay. But again, so clear A is going to put 0 in A. Load 0 in A is going to put 0 in A. Okay. They are the same. But there may be some differences in flags. If it doesn't matter for you, that's okay. There also may be some differences in the size in the memory. The size in the memory, or maybe the speed. Okay, if it doesn't matter to you, okay, so you're the same. Okay. So here we have clear A, clear B, clear memory location. Okay, guys, we don't have set instruction for register. Now also we have clear for flags and we have set for flags. If you want to clear one flag, if you want to set some flags, and you will understand later in this course why sometimes I need to set some flags, or sometimes I need to clear flags. Okay. So for example, here we have clear C, carry flag. So after you execute this instruction, you actually clear the carry flag. Clear I flag. I didn't talk about this I flag. Okay. I flag, I'm going to explain it later in this course. I flag is actually the interrupt flag. Interrupt flag. Okay. I'm going to explain it later in this course. We're going to need it in this course. So here you can clear the carry flag, you can clear the interrupt flag, you can clear the B flag. Also, you can set the carry flag. No space here, guys, just one word. Set the interrupt flag, set the B flag. Set means you put 1. Okay, so that's all what we have. So we have 3 instructions in order to clear some flags or set some flags. Okay, that's all what we have. So I have just examples here. So number one, I can ask you, can you clear the byte at memory location 1000? Yes, you can say clear 1000. Okay. Another way you can do it, you can say move byte 0 to 1000. Again, they are the same. Okay. Okay. How can you clear a word if you have a word at 1000? How can you clear it? Right. So now I can say clear 1000, clear 1001. Should be okay. Look here, guys. I know it's a little bit confusing. Listen to me. When you have a word, based on what I explained right now, if you have a word and you want to if you want to clear it, if I clear it separately, it's okay. It's gonna work. By common sense, So if I say clear this one and then clear this one, so I'm gonna clear everything. Same thing for complement. When I say complement here is gonna work. However, when I try to do it with negate, it didn't work, right? There is another one, I don't remember. I tried to do it, I don't know what operation. So what I want to say, in some operation, if you do this operation separately on the 2 bytes, should be okay, right? In other operation, it's not going to work. There is another one I mentioned before, right? When I tried to do it, it didn't work separately. I don't remember which one. Okay, so now for clear, just one more example and that's it. So here for clear, I can say clear 1000, clear 1001, okay? Or you can say move forward 0 to 1000, the same thing. Also, if you want to clear register D, you can say clear A, clear B, or you can say load G with 0, put 0 in G, okay? So I want to just tell you guys, I'm done. I'm not gonna explain, just 1 second. I'm not gonna explain anything new. So what I want to tell you, in this chapter today, I explained arithmetic instruction. I started with addition and subtraction. I give you examples. And in this table, I put all the instructions we have for addition and subtraction. Also, I explained here decrement and increment, and the summary here for decrement and increment, they are here in this table. Also, I explained clear, complement, negate, and the summary is here. There are not many instructions, but these all the instructions we have. I also give you examples. Okay, so all what is left in this section is multiplication and division. I'm gonna do it next time. Okay, after that we're gonna go to branch and loop. Any questions? Okay. Again, before you leave, the quiz is going to be on data transfer instruction. The lab is going to be about data transfer. The first part of the lab is about data transfer instruction. The second part is going to be addition and subtraction as well, including addition and subtraction. Please, guys, for labs, do the lab before you come. You are not going to have enough time to think about the lab when you come to the lab. So you have to do the pre-lab before you come. Okay.